Hey guys, welcome to CCL Biology, the channel for easy to understand biology lessons. If you are a high school student who needs just a little bit of help with your general bio or AP biology class, or even if you're a college student taking an intro bio course, this is the place for you. I am your friendly bio nerd. Thanks so much for tuning in to my channel. In this video, I'm going to be talking about covalent bonds. So if you want to get a better understanding of covalent bonds, then stay tuned. While you're here, please be sure to hit the like button below if you find this video to be helpful. And if you want more easy to understand biology lessons, then be sure to subscribe to my channel and click the bell to get notifications for new videos that go up every week. Okay, as I said, we're going to be talking about covalent bonds in this video. We're going to take a look at what they are, how and why they form, and we'll also look at some examples. So let's go ahead and get started. What is a covalent bond? A covalent bond is a chemical bond that holds two or more atoms together. Now, there are some parts of this definition that need a little bit of unpacking. First off, with atoms. Now, if you want an in-depth review of what atoms are, then be sure to check out my video called All About Atoms, and I'll post that in the description box below. But just for a quick definition here, an atom is the most basic unit of matter. Now, atoms can come physically close together with each other through chemical reactions that create chemical bonds. But why? Why would atoms come together? Is this just something they randomly do, or is there a reason for it? Well, there's definitely a reason. Atoms are trying to fill their valence shells or complete their valence shells. Now, I talked in depth about valence shells in another video called Valence Electrons, so be sure to check that video out as well. But here I'll just say that atoms are not fully stable when their valence shell is not complete. And what I mean by having a valence shell that's not complete is that they don't have the maximum number of valence electrons possible in that shell. So when an atom's valence shell is incomplete, that causes the atom to react with other atoms. It comes close to other atoms and either forms bonds or breaks bonds because it's trying to fill its valence shell so that it can be complete and stable. So one way for an atom to do this is to share its own valence electrons with the valence electrons of one or more atoms. So one atom can share its valence electrons with another atom of the same element. For example, two hydrogen atoms can come together to share their valence electrons, and that's what we see happening here. Also, an atom can share its valence electrons with an atom of a different kind of element, like hydrogen and oxygen, as we see here. Now, we'll look more at how that sharing happens in just a little bit, but when atoms come together with that bond sharing their electrons, they form what's called a molecule, and the bond that's joining each atom together is a covalent bond. Now, this is the strongest kind of chemical bond there is, that covalent bond. So there are quite a bit of chemical bonds, so the way that I remember that covalent bonds or the sharing bonds is that co part of covalent. It's like these bonds are causing the atoms to cooperate with each other as they're sharing the electrons. And I remember that covalent bonds are the strongest because we're always stronger when we share, right? So that's just a little trick that I use to remember them. Now, not all atoms form covalent bonds. Covalent bonds are used for nonmetal atoms and halogen atoms. So let's take a look at the periodic table to see what I'm talking about with nonmetals and halogens. Okay, so of course, different periodic tables are going to have different colors, just depending on what they're emphasizing. So this particular periodic table has about 10 different colors, and each color is telling us what kind of element we are looking at. So there are 10 different types. So here, these light green atoms here, these are called the nonmetal atoms. Now, as you can see, they're mostly all to the upper right corner, but also hydrogen falls into this category of nonmetals as well. And then further to the right, these light blue atoms here, these are your halogens. Okay? So it's your halogens and your nonmetals that form chemical bonds with each other, or form, covalent bonds with each other. Now, one single atom can actually form more than one covalent bond at a time. So what I mean by that is one atom can share its valence electrons with two or more different atoms at the same time. So just looking at this picture here, you can kind of see what I'm talking about. If this red ball represents one atom, and then each of these gray balls represents an atom, we see that the red atom, it has a bond with more than one atom within the same molecule. Now, not every atom can do this. It typically depends on how many unpaired electrons the atom has in its valence shell. Now, again, be sure to check out that valence electrons video just so you can get a better understanding of what I mean when I say unpaired electrons. Now, some atoms have just one unpaired valence electron, like we see here with lithium. So if we're looking at that outermost shell, that's the valence shell. So lithium has one unpaired. Some atoms have two unpaired electrons, like we see with beryllium, 1, 2. Some are like boron with 1, 2, 3 unpaired electrons, and then some have the maximum number of unpaired electrons, like 4, which is 4, like we see here with carbon. So 1, 2, 3, or 4. So again, the number of unpaired electrons typically corresponds directly with the number of covalent bonds that atom can form with another atom. And this is called the atom's bonding capacity, or its valence. Now, I actually really love language and word and the origins of words, and that really helped me out a lot in biology, so hopefully it'll help you too. So valence actually comes from a word that has the root that means power, or like capacity. So an atom's valence is its power or its capacity to bond with another atom. Okay, so now that we talked about what covalent bonds are and why they form, let's take a look at some examples of covalent bonds. So one simple example that we can start with is a hydrogen molecule, which is formed by two hydrogen atoms coming together. So I'm going to draw that here on the screen. Okay, so I am going to use a blue circle to represent my nucleus. And hydrogen has just one electron, which means that it has one electron shell. So I'm going to use this black circle to represent my electron shell. And then I'm going to use red to draw in that one unpaired electron. Okay. All right, so as I said, a hydrogen atom has one electron in its valence shell. Now, for that atom to become complete in terms of having the maximum number of electrons that it can hold in its electron shell, it needs just one more electron. Then it will be complete and stable and not have to react. So it can get that extra electron by sharing its valence electron with a second hydrogen atom, like we have here, because the second hydrogen atom also needs just one more electron. All right, so these two atoms would come physically close together, and we would have a covalent bond form between them. So I'm going to draw that. Okay. So the valence of hydrogen is 1. It has one unpaired electron, which means that it can form one covalent bond with another atom at a time. Okay, now let's look at an oxygen molecule, and that is made of 2 oxygen atoms. So again, I'm going to use blue to draw in each of my nuclei. And an oxygen atom has a total of 8 electrons, which means that it needs 2 electron shells. So here is shell 1. Oops, what happened there? Shell 2. And then shell 1 and shell 2. Now let's use red again to draw in the electrons. So the first 2 of the 8 will go in the first shell, and then the remaining 6 go in the valence shell. So there's 1, 2, 3, 4, and then they'll start to pair up. So 5 and 6. Okay, so again, you see here that an oxygen atom has 2 unpaired valence electrons. So we see that in each of my oxygen atoms, and its valence is 2. Now, to become complete, the oxygen can form a bond with 2 different atoms at the same time, or it could bond with just one atom. Now, wait a minute, let's back it up. If oxygen needs 2 more electrons to become complete, then how could it do that if it bonds with only one other atom? Well, it would have to form what's called a double bond. And that's exactly what happens when these two oxygen atoms come together. So let's take a look at what's going to happen there. Okay, so let me explain what's going on here. I know this drawing looks horrible. Please don't judge me, just go along with me. So we see that the two oxygen atoms have come together. So each oxygen still has 8 total of its own electrons. So here, look at this atom, we see 1, 2 electrons in the first shell. We've got 1, 2, 3, 4. So these are paired and these are paired. I'm going to come back to that count. And then here we have the yellow electrons, 1, 2 in the first shell. And then we have our 2 pairs here, 1, 2, 3, 4. So that's 6 that we see in pairs and 6 that we see in pairs. So what's happening with the other 2? So the other 2 unpaired electrons of this oxygen atom came together to share with the unpaired electrons of this oxygen atom. So that's what I use the orange for. So the orange is showing the electrons that are now being shared, and they're forming pairs as they're doing that. So perhaps these 2, may belong to this atom, and those 2 originally belonged there. So now they're sharing. So that may be a little more clear. So 6 valence electrons, 1, 2, 3, 4, 5, 6 on that side. 6 valence electrons here, 1, 2, 3, 4, 5, 6. Okay, and they are sharing. So now both the oxygens are happy because they have full valence electron shells. Each of them has 8 electrons. So now that is a complete molecule. Okay, so I kind of cleared that off the screen too fast, but hopefully you got the picture. But if I wanted to represent that oxygen molecule, that O2, in another way, I could do it like this. All right, so in here we have the 2 O's, which represent the 2 oxygen atoms, and then you see 2 lines in between them. So those 2 lines are showing that there is a double bond, which means that 4 electrons are being shared. So again, back when we drew the hydrogen molecule, there was a single line in between the 2 H's, showing that there was a single bond and 2 electrons were being shared. So you've got a single bond, you've got a double bond. You can also have atoms that are sharing, and they create what's called a triple bond, where 6 electrons are being shared. So that would be something like dinitrogen, and that would be represented by the 2 ends with the 3 lines in between them. Okay. So now let's join 2 different atoms together. Let's do oxygen and hydrogen, since we've been working with those. All right, so just to save some time, I've drawn them here. So we have our hydrogen atom with its nucleus and its 1 electron, and then we have our oxygen atom with its nucleus, 2 electrons in the first shell, and 1, 2, 3, 4, 5, 6 electrons in the second shell. Now remember, oxygen needs 2 electrons to become complete, and hydrogen needs only 1. So can these 2 atoms help each other if they don't need the same number of electrons to become complete? Yes, they can, but we're actually going to have to bring another hydrogen into the picture. All right, so I'm going to draw in another hydrogen atom. So there's my nucleus, my electron shell, and my 1 electron in that shell. Okay, so what's going to happen here is that each hydrogen atom is going to share its 1 electron with oxygen. So it's going to give 2 electrons to share with oxygen. So now all the atoms are going to be complete and they're going to be happy. Oxygen is going to get the 2 electrons it needs, 1 from each hydrogen, and each of those hydrogens is going to get the 1 electron that it needs. Okay, so I've drawn this kind of upside down looking Mickey Mouse thing here. But this is my oxygen atom covalently bonded with my 2 hydrogen atoms. So here we have our oxygen, and you see the first 2 electrons in that first shell, 1, 2, and then 3, 4, 5, 6. So I'm going to come back to the last 2 electrons, because remember oxygen has 8. And then we have 1 hydrogen here, nucleus, 2nd hydrogen here with the nucleus. Now the orange electrons here are showing the electrons that are being shared. So oxygen, again, let's go back to those valence electrons. So 1, 2, 3, 4. So the fifth valence electron for oxygen, or inside of oxygen, is being shared with the valence shell of hydrogen. So let's say that's this one right here. Okay? And then this electron is the valence electron that hydrogen has, that it brought to the sharing table to share with oxygen. Okay? Same thing here. So the sixth valence electron in the oxygen atom is sharing with hydrogen. So we can say that's this electron here. And then this electron is the valence electron that this hydrogen atom brought to share with oxygen. So let's make sure that all of the atoms have the maximum number of electrons that they can hold and that they're complete. So hydrogen can hold a maximum of 2 electrons. So this hydrogen atom, we see 1, 2. So it's complete and happy. This hydrogen atom is 1, 2. So it's complete and happy. And oxygen should have a total of 8. So 1, 2 in the first shell, 3, 4, 5, 6, 7 there, and then 8. All right, so it is completely happy. So there we go. So we have the oxygen coming together with the 2 hydrogen atoms, and that is something that we affectionately know as H2O, or water. And this molecule is called a compound. So a compound specifically refers to 2 or more different elements that come together. So the 2 hydrogen atoms that we looked at earlier form a molecule. They formed a molecule, but that wasn't a compound because they weren't 2 different atoms. They were both hydrogen atoms. So that would actually still be considered an element because it's made up of 2 pure hydrogen atoms. Same with the 2 oxygens that we joined together to make that O2. That would be an element of oxygen, not a compound. But this H2O is a compound because it's 2 different atoms coming together. So we're going to go over that again with the molecules versus compounds. A molecule is made of 2 or more atoms bonded together. They can be the same atom or 2 different atoms, or 3, whatever different atoms. But they're bonded together, and it's always a covalent bond. Molecules are always covalently bonded. Whereas a compound is 2 or more different atoms bonded together. And compounds can have either covalent bonds or ionic bonds in between the atoms. So I talk about ionic bonds in a different video. Well, that is it for today's video. I hope that it was helpful for you. If so, please let me know by leaving a thumbs up in the comment section below. And if you have any questions, then definitely type them in the comment section, and I will do my best to provide you with an answer. Thank you so much again for watching CCL Biology. That is Christ-Centered Life. Thanks. God bless, and bye-bye.